Alright, ladies and gentlemen, today we're going to learn about Hess's Law. Hess's Law is comprised of two main things, or there are two things you're trying to get to in Hess's Law. You're trying to find the delta H using these given values, and you're trying to get these two equations, sorry for that stray mark, look like this equation up top. So those are the goals of a Hess's Law problem. And I'm going to take you through how we're going to do that. And I'm going to erase these stray marks. So the first thing you want to look at is what your products are in the main reaction. So in this main reaction, this one up top, and they'll always be separated, you'll have a main reaction and then you'll have subsequent little half reactions. So this main reaction, we have PCl3 as a product and Cl2 as a product. So it looks like in this first half reaction we have PCl3 as a product and we have Cl2 as a product. We also have Cl2 as a reactant in this problem, but because this is a smaller amount than this one's going to get canceled out. Alright, so the way we're going to do this to start is that we're going to try and make this reaction and this reaction look like this reaction. So in this reaction we have 4 PCl5s. In this reaction we want only one PCl5. So what we're going to do is we're going to divide this whole reaction by 4. Because that would cancel this 4 out and make this look like that. And we're going to rewrite it down below. So when we divide it by 4, we're going to have, and I'm going to keep them in order, so PCl5 turning into 1/4 P4. Don't let that trip you up. It's going to get canceled out. More than likely we'll always end up with whole numbers in the end. So don't let that 1/4 mess with you. Plus, this 10 divided by 4 is going to be 5 halves Cl2. Okay, now I haven't been writing the gas, solid, gas, only because it's not really going to be important for these reactions. So you can hold off on writing those. To make it look more neat and tidy, you would put those in. Alright, so this reaction is done for the time being. Now I look at this reaction, this first of the two reactions, and I see that I have 4 PCl3. And here I want only one PCl3. So I'm going to do the same thing. I'm going to divide this equation by 4. I'm going to write that over there just because I don't have space for it elsewhere. So now here on the bottom that changes to 1/4 P4 plus 3 halves. It's 3 halves because I have 6/4 and I can reduce that to 3 halves. Plus 3 halves Cl2 turns into PCl3. Alright, so now here's where my favorite part of these reactions go, because you get to start canceling things out and see the work that you've done. So if you see here we have 1/4 P4 on the reactant side, and in this reaction we have 1/4 P4 on the product side. Because they're on opposite sides of the arrow, they can cancel each other out. So those guys are gone. Now in the end, we want to have PCl5 on one side, PCl3 on another, and Cl2 on the other. So at this point in time, maybe you can see where it's going, maybe not, but that's okay. We have 3 halves Cl2 on this side, and 5 halves Cl2 on this side. So if we take 3 halves from this side and take 3 halves from this side, we'll end up with 2 halves, which is 1. Which is what we want. Sorry, I'm going to write it over here so it doesn't get confusing. 1 on that side. Now we have PCl5, PCl5, P4, oh sorry, I was going to the wrong one, PCl5, PCl3, PCl3, and then Cl2, Cl2. So this is done as far as the reaction is concerned, and we're going to do multiple of these. But the next thing you have to remember is that whatever you do to these reactions, you also have to do to their delta H's. So, because we divided this delta H by 4, we're going to divide it by 4 again. Because we divided this delta H by 4, or its reaction by 4, we're going to divide it by 4 to get new delta H values. So when you divide this number by 4, you get negative 609.75. And when you divide this number by 4, you get 859.5. And so your delta H, when you add all those values together, is 249.75. Now sig figs are interesting here because these numbers will always be single digit sig figs, and we don't want all of our answers to end up sig figs, so you're going to use the smallest number of sig figs here. So because we have 4 significant figures in both of those, our answer is going to end up being 4 significant figures. So our final delta H, what we're really looking for in the end, is 249.8. Alright, so we're going to take a look at another Hess's Law problem. I'm going to work 3 of these, so you'll have plenty of examples. Alright, so go ahead and take a second and pause the recording so everyone can get a chance to write this down. Okay, so this one presents a new challenge. In the last one, all of the products and all the reactants were on the correct sides of their respective equations. But in this case, our products and reactants are not on the correct side. The equation we're searching to find, or the equation we want to get to, is H2SO4 in liquid form turns into SO3 gas plus water. So we want H2SO4 on the reactant side, and we want SO3 and H2O on the product side. Unfortunately, in this first reaction, H2SO4 is on the product side. So what we have to do is flip this entire reaction and rewrite it down here. So we're going to flip it and have H2SO4 turning into H2S plus 2O2. Now, when we flip this reaction, we have to change the sign of the delta H. So our new delta H is actually 235.5 kilojoules. Okay, so when you flip the equation, like we did here, you have to flip the sign, like we did here. Alright, now it looks like this equation, we want water on that side of the equation. Here we happen to have water on both sides. Oh, interesting. So we want water vapor on the product side, and we need to cancel out the liquid waters. So the next 2 equations look to be fine, because we want water vapor on the product side, which we have here, and we want SO3 gas on the product side, which we have here. So the next 2 equations I'm just going to rewrite. So we have H2S plus 2O2 turns into SO3 plus H2O. So here, the fact that this is liquid and this is liquid and this is gas did come into play. So it's important to note them, but for the sake of time, I'm not going to write them. And last but not least, water in a liquid form turns into water vapor. Alright, and we're going to rewrite these delta H's. So our first delta H, because the reaction didn't change, our delta H doesn't change, so it's negative 207 point, nothing, negative 207 kilojoules. And the delta H for the vaporization of water is 44 kilojoules, same as above. Alright, now we don't need to multiply any of these equations by anything because they look like they're going to cancel out nicely, so let's start doing that. I see two O2s there, two O2s there. We don't want O2, so that's handy. H2S there, H2S there. We don't want H2S, so that's handy. And a water in liquid form from the products and a water in liquid form from the reactants. So we're left with H2SO4, SO3, and H2O, which is exactly what we want. H2SO4, SO3, H2O. So now all we have to do is total up our delta H's. And when you add all these up, you get 72.5 kilojoules. Alright, and we're going to talk about the sig figs later because sig figs with addition have slightly different rules, but I'm not going to get into that right now. So just write your final answer as you calculate it. Alright, one last example problem and then you guys will be able to work on your own. So go ahead and pause the recording and give everyone 2 minutes to write this down. Alright, so find the delta H for the reaction below given the following information. 1/2 H2O plus 1/2 Cl2 turns into HCl. Alright, so things to note. We want to get to this top reaction. That's our goal. So the first thing we see is that we have half a hydrogen plus half a Cl2 turns into hydrochloric acid gas. So hydrogen chloride gas. Alright, so we want Cl2 on the reactant side, and right here Cl2 is on the product side. We don't want that, so we're going to have to switch this equation. And let's see, HCl happens to be in this same equation, and it's supposed to be on the other side, so that's great. We'll flip that. And then H2 is in the correct position here. So we'll leave that alone. So we're really just flipping this middle equation. But we're going to rewrite them all just for it makes it nice when you're trying to cancel out. So here we go. COCl2 plus H2O turns into CH2Cl2 plus O2. The second equation is the equation we want to flip. So we're going to have H2O plus Cl2 turns into 2HCl plus 1/2 O2. Because we flipped that equation, while I'm thinking about it, we're going to go ahead and rewrite the delta H for that one. We're eventually going to rewrite the delta H for all of them. But the delta H for this is now negative 105 kilojoules. Alright, and last but not least, this equation gets to stay the same because H2 is on the reactant side and we want H2 on the reactant side. So we've got CH2Cl plus H2 turning into, plus 3/2 O2 turning into COCl2 plus 2H2O. Alright, and so now I'll go ahead and rewrite those delta H's because those ones haven't changed yet. Now if we have to multiply them by anything, they will change. So the first delta H is 47.5 kilojoules, and the second delta H is negative 402.5 kilojoules. Alright, so now let's take a look and see what's going to cancel out nicely. We might not have to multiply this by anything, actually. Oh, we do. We have to multiply this middle one. Oh, we're going to have to multiply two of them by that. Alright, so, sorry, working it out of my head. Alright, so, what we're going to have to do, because we want 1/2 of Cl2, 1/2 of H2, and just one HCl, because we have a full Cl here, or in this case a full Cl2 here, and two HCl's here, and a full H2 here, we're going to have to multiply the bottom two equations by 1/2. But if we multiply the bottom two equations, oh sorry, I just saw something else. What a rookie. That is CH2Cl2. Because we multiply this equation by 1/2 and this equation by 1/2, and we have a CH2Cl2 here and a CH2Cl2 here that we're going to need to cancel out, we're going to have to multiply every equation by 1/2. If we multiply every equation by 1/2, we'll get the correct answer. Alright, so this guy by 1/2, this guy by 1/2, this guy by 1/2. So multiply them all by 1/2. Alright, so I'm going to rewrite this one more time. That's going to get ugly if I rewrite it one more time because we don't have much room. So what we're going to do actually is just remember right in the beginning to multiply all of these by 1/2, because whatever you do to the equation you have to do to the H plus. So just going to remember that both of these are also times 1/2. So if you didn't run out of room, it's best if you write it over here. It looks a little cleaner and you'll remember that it applies to both, but I ran out of room. Alright, so now it looks like we have 1/2 H2O here, 1/4 H2O here, so technically we have 2/4 and 1/4, so we've got 3/4 H2O over here, and if we multiply this by 1/2, we also have 3/4 H2O here, so that one gets crossed out, that one gets crossed out, that one gets crossed out. Now we have 1/2 CH2Cl2 here, and 1/2 CH2Cl2 here, so those get crossed out because they cancel each other out. Here we have 1/2 COCl2, and here we have 1/2 COCl2, opposite sides of the reaction, so they get crossed out. Here we have 2 H2O gets multiplied by 1/2 or divided by 2, so it's just one whole H2O. Here we have half an H2O and another half an H2O, so that's one whole H2O on that side, so these combine to be a whole H2O and cancel out that H2O. Now what we have left is 1/2 multiplied by 2, so we've got one whole HCl. Here we have 1/2 multiplied by 1, so we have 1/2 Cl2. And here we have 1/2 multiplied by a whole, so we have 1/2 H2. And this is the completed half reaction. Looks just like that. Alright, so now that we've done all that, the final thing we have to do, multiply all these values by 1/2 and then combine them. Alright, and when you do that calculation, you get that the final answer is minus 225 kilojoules. So that is your final delta H. Because remember that this one was negative and this one was negative. Alright, that is how you solve Hess's Law problems. Good luck on your worksheet. We will go over it tomorrow before we move on to anything else.